So what Mopsy is, it can be defined as some kind of location-based social network, even though more recently the number of users active is very low, and I am not there anymore. So the main reason for this is that in recent years it stopped being supported, and connections to existing third-party APIs, so this links to what we talked about yesterday, have fallen. They haven't broken, these connections haven't broken entirely, meaning that it still works somehow. If you implement it really poorly, some software that depends on some specific API, then you're going to have trouble if you're not being supported by that API anymore. But in our case, we had quite many backup solutions that started to become back into place, but attractiveness of the application started to go down when, for example, Facebook publishing stopped working. And logging in with these different accounts is also not supported anymore. Several other things would need attention, especially the mobile environment. So Mopsy actually has mobile downloads here. That should be available for most platforms. We have support for Windows Phone, iPhone, Android, even the old Symbian Nokia phones. And Mopsy, which we talk about some other time, has the support as well, but it never ended up on iPhone, the App Store. Now, if you try to open these, I don't really know if they are still on the stores. This one says temporarily unavailable. This one just lets me download the APK, so I believe we removed the one from the store because it's not supported anymore. I think one of the Mopsy games is still there. So Mopsy you can still install on your Android phone. The reason why this one is still there, I haven't checked, but when the people take down an application from the App Store, it's because the apps don't meet some requirements. They were all of them there, but requirements change. So the thing is that whenever you plan your applications, say you want to make an application, you want to make a program, keep in mind that your job will not be done. It's very unlikely that your application will be totally independent. So it will rely on some APIs to become popular, otherwise just unlikely for it to be as used. But when you make this contract with somebody else, even if it's a free service, you need to make sure that you update your application whenever they request you to do it. So the reason why this one is there is probably because it wasn't so featureful as Mopsy. So maybe they didn't like something in Mopsy that needed a specific permission to be added or something like that. Like maybe we weren't handling well enough camera permissions, or the camera permissions changed a little bit, because in Mopsy you can take pictures and then the pictures have geolocation added to them. So in Mopsy you don't do that. So this is just an example. I'm not sure if it's the only reason. If these camera permissions changed throughout the years, then your app has to somehow change as well to adopt these things. And since we haven't done it for 2 years, probably it's one of the reasons. I know specifically why Windows Phone Marketplace rejected our app at some point. It was because we didn't have a checkbox next to the login system that said that you are over 13 years old. So we had to update the app to include this checkbox. You have to press it and only then you can click the login button. Now from a realistic perspective, this wouldn't prevent somebody who is not 13 years old to play the game, but it was in their law, in their requirements, that all applications have to contain this if they use location. If they use location and means of communication with somebody, I think it was. So the application has also a chat on the mobile, so you could talk to anybody who is logged in. So it was a valid concern, I think, and but I don't think that this checkbox really helps solve the problem. But anyway, they took it off, and then maybe 2 weeks it took time to get it back up, because you needed to modify it, but then people have to review it. And I guess they were reviewing apps all the time. So anyway, so this one is, I mean, the Mopsy app is not just one app. It's actually all of these apps from here and the website. And you can see that a lot of human power, a lot of resources, and constant awareness is needed. There was a time when all of these were working perfectly. Not perfectly, bugs were always there, but you could download the apps and install the apps without issues. Okay, both of them are not on the Windows Store anymore. That was my responsibility at some point. Anyway, so let's go back to Mopsy now and see some features that are available in it that still work. So I'm going to focus on the things that work. First, we have here the user's screen. So this is supposed to show where active users are. It uses some color coding here. So more or less, if I would log in now on my phone, it probably will show me appearing there as red. Probably it will show me appearing as red, and the other people were active, I believe, last week and last month, I mean this month. So everybody active in the last month is in that list. And it's a very short list, but the database has quite many users, maybe like 5,000 users. They are mostly empty users who made the account, tried it for a few seconds, and then they stopped using it because of whatever reasons. Most likely, say somebody from Germany installs the app and the nearest person is in Joensuu. No point of interacting with the person. No friends nearby that may encourage you to use it. So this cold start is actually an issue. How to get it so that people from a faraway place where there are no services, where there are no friends, can benefit from it. Because he really didn't have any use for it other than maybe recording his trajectories and analyzing them, or taking pictures and using it as a gallery. More or less. But Mopsy has many other features that I will show. Okay. So this is also one interesting example here now, that it actually shows me at the correct location. I guess it uses maybe some IP or Wi-Fi or whatever system to position me. But interesting is that the Google map we use on the background shows the building as Technopolis, but the name of the building has changed to this Novapolis recently. So this is just another example that even Google or whatever service providers you are using may not have the correct information. And this is especially obvious in Mopsy because here we can toggle to different service providers. So if I'm going to put here a mark where, for example, this intersection is, and I'm going to change back to the Google map, I see that it's a little bit a different location. Now, how much is this? If this is 50 meters, then this is more or less 1 or 2 meters difference. It's no big difference. But in practice, these differences can be even hundreds of meters. So it depends about the location where you are. And if you check, for example, this spot here, we can see maybe this structure in OpenStreetMap, which doesn't exist at all in the Google map. So these differences between the service providers, which one is more correct, which one is not. Here we have the possibility to use the satellite image from Google. We see that there is some building there. It actually seems to be also visible in the OpenStreetMap as this box there, but maybe some kind of parking place or whatever roundabout thing here is not shown in this other one. So which one is correct? Both of them cannot be correct. Satellite view from Google tends to say that OpenStreetMap is correct, but the satellite image from Google, I don't know if the year, if this copyright year is actually the year when the photo was taken. This seems to be anyway summer. Everything is green here. It's a bit hard to see. So could it be that maybe this building is not there anymore and the map data is correct? These are questions that are very hard to answer, and they know more or less better than us. So there is no absolute solution there from map service provider. None of them is going to be perfect. Then we also have another map thing here, which actually took very much efforts to do. I don't know if they work anymore, but okay, they actually work. So if you are familiar with this suunnistus, with orienteering, then these are maps that are used for orienteering. And we have had a summer worker, high school student, I think it was Jonas, and we were getting these orienteering maps from Kalevan Rasti, from this local orienteering club. And the problem with this thing was that they were aligned by magnetic north, not geographical north. And would you believe that they are not the same thing? So geographical North Pole is a different location than the magnetic North Pole. And that means that Jonas had to switch all of the maps by about 10 degrees to rotate them manually in, I think he was using Photoshop or something. I don't remember what software we had at that point license for. But anyway, so he was doing that manually, but the thing is that depending on the longitude, this angle is not the same. So he would have to try different angles, maybe 10.1, 10.2, upload again, stretch a little bit, make it fit on the map. We had a specific tool for that. And Yeah, this was actually manual work. It could have maybe been done a little bit more automatic, but then again we had the student and we needed to give him something to do, and this was one idea that came to mind, plus that the maps were a finite number of maps, after which we wouldn't need the automatic tool anymore unless the maps change, which they do, but again, a compromise between the two. So these maps are really high quality maps. They contain all kind of different information. I don't know how to read all of them, but I believe that these dots mean rocks. So even big rocks are marked in the forests there, and you won't find this kind of service elsewhere. There are these. There is this. I think it's from the National Land Survey of Finland. There are some maps that are really high quality, but they don't go to as much detail as the orienteering maps. These maps are actually generated by people that are passionate about the sport and that are walking, and they measure the distance with their steps, and they put down all the observations that they see, and they make the maps manually with very high accuracy and many years of experience. So anyway, we do have these here. I don't know exactly how many we have, but Jonas did do some work. They are mostly around Joensuu, because Kalevanrasti has these maps there, but also in some nearby places like in Koli. Yeah, you can see some of those. Okay, and you may ask, why do we have this white option? Well, it's more or less for research point of view. So sometimes when we want to take screenshot of something, we don't want the map to be overwhelming. And when we don't want that, then we just take a screenshot of whatever we want to demonstrate on the map. Maybe it is, maybe it's like GPS trajectories or something. Okay. Something is not working today either. Okay, something works now. Refresh is your best friend. Okay, so say you want to display just some trajectories, but you don't want the map to interfere with it, then you can have a screenshot like that, and you don't need to plot the trajectories in Excel or in R or whatever other software. You can just use the Google Map to display the paths. Okay, so if we go back to this mode from here, you can see that the color coding is some idea. So it indicates something already without going and investigating too much further. So it does give you more information than simply using a simple marker there. Just at a glance you can figure out that, okay, there is more recent activity in central Finland than in southern Finland, and okay, Pasi is also active in the last week in China, and somebody, I don't know who it is there. But anyway, so a different information, and you can also see clustering happening here. So Radu and Irwan, who is probably playing with the app in Joensuu now. Yeah, he saw me lonely here and probably he logged in. Anyway, So you can see that when I zoom out, the users get clustered into a single marker. And this is happening because otherwise you would have overlapping markers, overlapping text that becomes difficult to read. And at some point this happens also here. So the second user's name disappears. Instead we use a counter for what is the size of the partition in this cluster. So how many items are in this cluster. We still keep the name of a representative. The name is chosen, I think, in order of recent usage. So since I'm online now, I have a priority there. Of course, this is not a perfect solution because we are losing some information now. We cannot see that Oily is somewhere here. She could be anywhere. But it's a way of representing that doesn't become too congested. The map doesn't become hard to read still. It may seem like a easy, neat, easy thing to do, but you wouldn't get this same behavior if you just rely on components from the APIs themselves. So if we look, for example, for marker clustering on Google Maps, you will very often find this visual here that looks like some kind of, well, maybe like some kind of signal emitting thing, or maybe like an earthquake marker or whatever. It does have similar information like the size of the partition, but if I would use this there, I could keep the recency information because it seems like the color coding is applicable. I could color them differently, but I lose the information about the person who is active most recently. So this way of visualizing has a little bit less information available for the user. And if I were to check our solution for the photos, I really don't take many photos, but Pasi still takes quite a lot. The last month he's in China. So the photo clusters, you can see they are even more complicated. So the photo clusters, what they do, they still have the number there indicating how many there are in a given location. But we actually choose from them one photo to display to the user. This is again giving more information, because if you are going to go maybe to let's say Christmas is approaching, you go to a Christmas market and you start taking pictures about the Christmas market. All the pictures in that location will most likely be about Christmas stuff. So you choose one, you display it, and then people immediately can figure out that, okay, probably the rest of the pictures that are about that, I'm maybe looking for something else, so I don't need to open this cluster, change the map and everything, and then have to go back again to fix the mistake because I was looking for something different. So he has quite many of them, many photos, 300 last year, all photos. It should load faster. I'm not exactly sure why it takes so long, but probably thousands. While it loads, we have some kind of API for this. So this clustering that actually keeps the photo, and page hasn't been updated for a while. You can include it in your own applications, but I think that the API is not very friendly. So there may be some issues with that. The thing is that it also was a research paper done by my colleagues. So different research questions were there. How big should the cells be? This is using some grid-based clustering method. So more or less, if the things are going in the same cell, then they are going to be represented by only one picture there. Also, other questions like what happens if you do have the grid cells, and then from here, from all of these photos, you choose maybe as a representative this one, and then you have the same kind of problem happening here, and you choose a representative here. And the issue is still going to be some overlapping happening, because these two representatives that you have chosen were not in the middle of the cell, so you have some kind of algorithmic problem how to choose the photo representative so that you avoid clutter under this grid-based clustering solution. So anyway, it links, in this way, Mopsy was linked to, okay, wow, 22,000 photos. Well, anyway, so it seems like the cluster sizes are not shown anymore, probably after 100. And, well, Pasi was pushing towards this use clustering everywhere. And we actually have two solutions for using clustering. There is a clustering by time happening on the top part of the screen. So this clustering by time, you can see here, for example, February 2012. But that specific cluster, I can open it, and in fact it probably started on February 2012, but it included these other months as well. So if I'm going to go to July 2012, yeah, this is the July part, from 25th to 29. So what is happening here, I believe this is just k-means clustering with a fixed number of clusters, and the number of clusters is set as how many fit in your screen. I am not sure because this was done before I came here, so 2010 maybe. But anyway, it's another way of representing the photos there instead of using a calendar, for instance. You could choose calendars to represent the photos. It's maybe a good option, or a grid. In a grid, then you can display them a bit better. This has some advantages because it only uses the top part of the screen, but probably it involves more clicks. Like every time you want to check these, you have to click, and then this back option is also in two places. So you can go back up the hierarchy that you have pressed to the main route. So two ways of accessing your photos. Either you can find all the photos that you have taken in Denmark, and then you will find there, even if you have visited maybe 10 different occasions, or you can go in the timeline view on the top and check these collections by time. Advantage of using clustering there is that say that you're traveling twice somewhere. You're traveling once to Helsinki and once to Tampere. And once you go in the beginning of July, and the second time you go at the end of July. So if you use a calendar, it will group the photos from the beginning of July with the ones in the end of July in July. But a clustering solution will group the photos that are taken together in time. closely similar in time. So it's going to find a different cluster in the beginning of July and a different one at the end of July. And if you have one extra day in August, then calendar system, you have to go to the next page entirely, but the second cluster most likely is going to group them together. So in general, clustering does have an impact on the number of clicks that you are doing, but I think both of these solutions could be actually improved in some way. Okay. Now, how about I ask you a question, do you want a break or do you want that we finish around 30 past 3 o'clock? 30 past, okay. Because I was overtime a little bit yesterday, so. Okay. Then photos, trajectories I have already talked to you about, so more or less you have seen how those are in the lecture on trajectories. I'm not going to go more details there, but I am going to show what other things are in Mopsy. So another thing that we have are errors. No. Okay, I was not on the right tab. This tab is for services, so I can move the marker, which for some reason is now at 0, 0, and then I could recommend some services in the region. So this recommendation system uses a database of services, but also a database of pictures. We can give ratings to services. So the services that are appearing here, if I'm going to log in, and now I'm not logged in, I can actually click on these stars and give a rating for these specific things. We collected these manually. So about 8 years ago we had these weekly agendas and we were like, okay, who takes care of swimming pools? Who takes care of restaurants? Who takes care of tennis courts? Who takes care of everything? And then for the next week or month or so, we would add more things into Mopsy. Now, how to add things into Mopsy? Okay, from this marker, okay, I think I need to be logged in for it. Just a second. Add service. So this add service button, it may look like something really boring to do, and it is, but very much research has went into this. So from research point of view, let's say that I'm going to go and add a service, maybe this Technopolis. So I would at some point need to find a link for it, but okay. Anyway, so if I have the link for this service, for example, adding it here, we have options to do things automatically from this link. For example, in the title, I could have a button that hopefully still works. Okay, so it figured out that the name of the service is Technopolis, and I have to say that you are probably not surprised about this. I mean, how hard can it be to extract a title from the web page? But in Najla's research, we have found that only 5% of the websites have the title of the web page in the title tag. I mean, in the HTML title tag or meta tags there, only 5% specify it there. Others put it, for example, as text, like H1 tag or something like that in the document. But very, very, very common what happens is that they are included in pictures, in logos. So it's not even the text itself there, but it's part of an image. In this case, most likely the method figured out that that the URL is so simple. It's not like a Facebook page or something like from some service provider. So it could have taken the title from there as well. I don't remember all the features that Najla uses, but she looks at the URL, she looks at the headers that are showing big text, she looks at words that are repeating abnormally much. Like, for example, if you have a service about, if you have a restaurant, then you may see in the text itself, come to visit this restaurant, us at, let's say, Rosso. And at Rosso you will find the best blah blah blah, and then welcome to Rosso, to blah blah blah. So they repeat this kind of title there. And Rosso is a word with a relatively low relative, is it called relative frequency? So frequency, general frequency, so that people don't usually say that word very often. If you just search all the Wikipedia articles that include it, it's very less used, the word. But it's especially much used on this specific page. So some kind of, these are all some kind of text manipulation features. And the same goes for these keywords. Let's say that I want to extract keywords from the website. And now I'm getting some keywords here, but they are not very good. There are methods also for extracting the keywords, but most likely this is not a language independent one, what we have here. But anyway, at least part of these things I don't have to type there. I don't know if any of them are useful, but anyway, so another automatic method that you don't really see elsewhere, it's hidden somewhere into Mopsy. Then we also have this, but I have a feeling that it's broken. Oh no, it's not. I think I actually fixed it recently, but I forgot. So it's possible to also extract a photo from the web page. The way of extracting photo, also scientific paper that Najla did with Andre, I think. And it was a very simple paper. It tried to be really fast, so you don't wait too much time. It was looking at properties of the photo, like, is it too small? Could it be like a small thumbs up picture or a smiley face or whatever? Or is it very long? Because that could be a banner or a logo. So it was looking at aspect ratio and size and very simple features like that. It wasn't looking at what pixels are inside and what is the content of the photo. Here I don't think these are especially good, but I'm not even sure where it got that picture from. I'm also guessing that this site is loading mostly dynamic. So in the HTML code that this method is processing, it's not seeing some of the pictures that are loading later, a little bit later. Anyway, so you can create services like that. You can also look at nearby photos here instead. So these are pictures that somebody, well, it should be, I don't know why. Oh, I think my location is not exactly where it is. Well, not very far, but not very useful either. Getting better. Anyway, so I don't need to physically go and take a picture of something because somebody else in Mopsy may have taken a picture of it before, and I can create the service much more easily. So these may look still tedious, a lot of clicking involved, managing the database manually, but it's actually quite a lot of stuff behind the scenes there. Okay, Mopsy did a lot of other things at some point. It did these bus systems, so it was very hard times. So I remember when I started, one of the first things I ever did in Mopsy, I got the job to go to Kouvola because we were partnered with the city of Kouvola, and okay, in that time, every summer and every winter, new buses change. And when the new buses change, you get on a paper the new routes and the new times. And exceptions are done like with the marker on top. So no form of electronic format for the bus schedules. And I couldn't just revert to the calendar from last year because of all these marker changes. Like, okay, new bus is going on this route, and on Wednesdays it's gonna do this extra loop, and on holidays it also takes these kids to school there, and or some kind of strange thing, strange exceptions everywhere. So we had quite a hard time figuring out how to do this bus system and how to manage databases with bus schedules at that point. But now we don't do that anymore. So what we did when the data became public, maybe about 2 years ago, so now all the bus data is available for the entire Finland, we started to use the API from there. Maybe it's called DG Transit, or I'm not sure. I'm not sure, even though I think I did this. Well, API. It's possible. I'm not going to look too much in. It's most likely this. If I remember the name, then it's probably that. So we started to use this API instead, and it wasn't too complicated to do, but all the functions that were supposed to work with the data from our database needed to learn how to work with data in new format. So there was some work to do. We just made a parser from the format in the API to the old format that we have, and then our functions were applied directly, but no more database involved. So when we were reading from this service, we just put in the format that our functions were expecting to get, like from our own database, a parser. Anyway, so a lot of stuff, and we even had algorithms about going from A to B I don't know if these even work anymore because this algorithm was database dependent. I should try also in Joensuu because Joensuu and Kouvola were the only ones where we actually had the data. Wow, this actually works. So we had algorithm that can tell you how to get from A to B so that you will have to maybe even change bus in the middle. So this was quite complicated thing. This works, but I would never trust this because I know that this works with the old data from like 5 years ago. So these bus schedules that are given here now in this format, they are not coming from Digitransit. Digitransit is only this this next bus search. How do I even get it back? Yeah, just this one where you can move the location to some other position, and then after you move it there, it recalculates and it gives you routes to different places in the city. So this other feature that we got it to work with the new database simply says you are here, these are your options. So something like that. Okay. What else? Well, if this works, we had also the profile page. Don't know if it really works well anymore, but okay, it loaded something. So we have here a recent activity from February and April. So these are something called user actions. They are things that are detected automatically by the system and summarized. So it just says more or less what the person is doing, but also detecting some more complicated things, like if two people are meeting or more people are meeting. So these meetings could actually be any number of people. So there is some clustering happening there as well. It's actually quite complicated system. So it's research again here. The idea is, how do you detect if two people are together? So you could say that, okay, these guys are together because they are forming a cluster, and maybe the distances here are not very big. But if these guys are actually traveling on, let's say, on a train, if they are traveling on a train, then they will update their location in sparse intervals. Not everybody is going to share their location synchronized with everyone else. So what that happens is that in the course of time, the location actually changes like this for one particular user, and maybe it changes like this for another particular user. So the distance between these guys is never small enough, even though they are in the same room there but moving. So detecting this togetherness while moving is also something that needed to be handled, even though the end result was just a small text here saying that somebody is meeting somebody. On the background there is this type of processing being handled there. So I think what we were doing, we were interpolating the location of the user of all users at a given time. So more or less, if you have a time given here, then we would say that they probably have been on that like 1 minute ago at this location, both of them, even though this is artificial data. So we only know for sure these location updates that are on two sides of that line, and for sure doesn't really mean anything because GPS error can be quite big sometimes. Like if you have some bouncing effect or if you're indoors or whatever. So that also had to be taken into account, and we had some kind of tolerance. So you need to be there together for some specific amount of time. Otherwise it could be just me opening the phone now here, and maybe my location just jumped to Joensuu next to Irwen, who also logged in. So it would show that we have met even though I am here. So it would show Joensuu because that was the last location that my phone has used. So for a brief second, this jump would need to be tolerated somehow. Okay. Then going back to this recommendation, so I showed how we got the services. It was mostly manual work. Since then, we have also gotten some extra services from people that gave them to us. So there is a service called A View on Cities. I think it was placed in Germany, but anyway, I'm not exactly sure. You can research it. So they gave us their database. We added it here. It's a database of things that people visit when they are tourists in other cities. So like churches, statues, museums. I don't know, it depends what is in that specific city to visit. And we have that as well in Mopsy. But how the recommendation works, so this recommendation, it selected 20 items for me that I may be interested in Kuopio here. And it works using 4 different factors. So it scores the items in the database with respect to their rating that they have gotten from other users, their distance to me. So now Joensuu places will get a very low score because the distance component makes it lower. About my past activity in Mopsy. So for example, if I have been searching here for maybe pizza places. Wow, only 3 things in Kuopio. Okay, so if I'm searching for that, then now it recorded that, hey, this guy is probably interested in that. So it's going to give a high emphasis to services that have the keyword pizza in it. So the keywords are here, and we also in the beginning mostly did them manually there. Some are in English, some are in Finnish. It's a mess, very difficult data set. People use the data set these days. So we have made the data set public. If you go to data and then Mopsy data, probably Mopsy services. So people use the Mopsy services dataset because it's actually a very hard one. It has multiple languages. It has also geolocation there. They can use for varying tasks. We also have here similar datasets with newspaper articles. So again, the services have also a link, a web page link. So we have location for them, we have photos, keywords for them. You can use it to do keyword extraction. You can use it to do title extraction. You can use it to do extract representative image or find a representative image. So all of these different tasks are still actively researched because there is no method that is the best. Some are fast methods, some are slow but better methods, some are too specific methods like only works in English language or something like that. And even those are not like 100%. So these type of data sets, including the one that we have extracted from the services, and we have also other type of data sets here, they aren't going to waste. So they are still being used by us and even by other people who are finding our work because we put linked with there. So if you're doing keyword extraction, why not try another free data set here? Okay, so this is more or less how the recommendation is working, but the method is not that simple as it may seem. So a little bit more things are there, not just those scores. The distance was implemented in a strange way because we started off, we didn't have spatial indexing for the locations. So what we do is, if our location is here, we start to increase the radius, we start to double the radius and look for services. Now we found just 2 things nearby. So we double the radius even more. At some point, if you don't find services that are useful for user, you will end up to the whole world. But let's say that you do end up to the whole world and you found too many things. Like all the data is in Joensuu, you are in US somewhere, and it increased all the way to Joensuu. And you still want to show those because maybe they are the only things that you can get. Let's assume a hypothetical scenario. You're looking for reindeer shoes and you are in USA. It will extend until you reach Lapland or something like that, and you will find a service there. But anyway, after the last extending step of this radius, what the algorithm does, it starts to shrink and go halfway between that and the previous radius that it has tried. If you still have enough services, then it's going to shrink again. If at some point you have too little again, then it's going to increase again. So it narrows down using binary search. We could do this because data set is not that big, and we didn't have spatial indexing then. We have now, so now we could use maybe nearest neighbor queries in 2D space. I think we use R3 indexing in the database, but I'm not sure because this is implemented inside MySQL nowadays. So if you use the MySQL spatial extensions, then this for a point object there, automatically it will most likely choose the R3 for spatial indexing. And there you can access methods like get the nearest 5 items or get the nearest items within a region, within a given threshold. Okay. How about you ask me stuff or comment about it? Is there anything that links to your project ideas, or if you have comments about your project ideas, I could go on with Mopsy because I'm now remembering very many other small things that I could talk about, because it really is huge. Like it's 10 years of work. It's more than 10 years of work, and I'm just presenting the web part, but I haven't gone to server side or the mobile devices. But since the projects are going to be mostly web, I think that it's the point to focus on this now. So how about it? Do you have something that you find useful or something that you find could be done better, or something that you would like to know more details about how it's done, so that you will maybe do it someday. Is this boring? Does it seem old? Do you believe that these research problems that I am saying here are actually still research problems? Because it may seem like if you use, for example, Google Maps or TripAdvisor or some very, very good systems, I mean, I don't know how good they are, but they are popular. It may seem that we have been doing more or less the same things. Now, if we compare this part, Mopsy has also these buses and trajectories, like sport tracking services can be compared, and other stuff. But the reason why those are much better is because of the infrastructure, one of the reasons. So they have many computers, they have a cloud system, cloud infrastructure. This one already, one reason why it's slower is because the server is in Joensuu. If I tried to demonstrate this in the conference last week, I had to reload the pages and I was waiting there for maybe 10 minutes to do something, and Pasi in China, I can't even access part of the things now. It would just take too long, because sometimes, like if you would do some kind of what I tried to do yesterday, like this. Like if I look now for similar trajectories here, okay, this is maybe a bad example because in Kuopio there are less trajectories than in Joensuu, but the idea is this list is going to be very long. It's going to load a very, very big list of similar trajectories to this input that you see here in green. If it works today, it didn't work yesterday. So this long list, now it takes some time to generate, but then after it generates, it will take time to download. And this download size of this list, I have checked a few weeks ago, it's something like 4 megabytes in the worst case. It's really big. Like sometimes you have maybe 1 to 5,000 trajectories in the list. So the list is not very useful. It has the useful things on the top, the most similar trajectories, but even if it has a minute similarity, like maybe just intersecting, it will be at the bottom of that list. So since it downloads everything, it would take for him so far away a very long time to get the information. Was there some question in Joensuu? No. Okay, but anyway, so if we would have virtual servers, if we would have more machines, replications of the databases, then the system would start to behave much more like these popular ones. But the infrastructure grows with popularity and time, so we are not getting popular when most of our features have expired. So this is a big problem that I would really encourage to think about. Can you make your service so that it somehow works even when some of the external APIs stop existing or update? Because when they update, you will need to suffer some time of inoperability. If you are a very good company, then you read the messages from the third-party APIs. They will say that it will change like this after a certain amount of time, and then you will schedule tests, you will run tests, and then when the release date happens, people don't even notice. But that means that your company needs a tester. Not many companies have testers. because small companies just hire a couple of guys that are doing developing job. Maybe they are going to know how to test and how to set up these kind of changes if they have experience from maybe a bigger company, or maybe they learn themselves somehow. But it will affect user experience, and users don't like to say that, I'm sorry, you are coming now to Google, but Google is out of order, you cannot search right now, please come again later. People will move to Bing or something else if something like that would happen, even to Google. Because most of the people, in my observation, they are really impatient nowadays. They want everything right now at their fingertips. And if something doesn't work, they will look for alternatives. So you either have such a good service, such a good application that nobody else can offer, and then your users will tolerate issues like this, or just try to be more reliable than everybody else. So in that weather app example that we talked about yesterday, having those kind of jokes or some kind of alternative reason that you would visit the application for, I don't know, how would I balance it? So if I compare now Foreca app or Ilmatieteen Laitos app, one of them is going to be different than the other, like from accuracy point of view. So one of them is going to make some mistakes, maybe sometimes the other one is going to make mistakes. I could start to do a solid evaluation, like how many times you were wrong, how many times you were wrong, and objectively choose an app based on its sensor accuracies throughout the world or whatever. But a normal user wouldn't do that. A normal user would look like, this looks funny. So these are very subjective things, by the way. You don't have to believe everything I say, so this is not coming from a book. I actually have a book on the web page that you can look for a systematic description of location-based apps. But the reason why I hardly even mention it is because it's outdated. These books are not part of the things that are told in that book are obsolete, and there is no way to teach this course from a book. They are changing all the time. Like part of that book, I think a whole chapter, maybe like 20 pages, is about map service provider, how much they cost, and what features they offer. But in 2011, Google didn't allow you to see the map as a globe. We just saw that very recently. And there's no point to teach like that. So I think that even though I may be sometimes a little bit off, I know the things better than in that book. So don't trust all the things that I say. It's just impossible to give you solid facts all the time. They are changing too much. So these last things were more or less advices, what I think is the case. But I can be very wrong. And if you think about applications as opportunities to go viral, then very funny things have happened. Like I think a year or a couple of years ago, there was this application that became very, very viral. Well, not extremely viral, but thousands of users, maybe even hundreds of thousands of users. It was this game, it was called Tap the Egg. And you have a game where you just have a picture of the egg or something on your phone, and you had to tap it 1,000,000 times. So people were doing this all day, mostly kids. 1,000,000 times, doing this all day. Meanwhile, the app had commercials or whatever in the corner. So anyway, and then at the end, after they tap 1,000,000 times, I don't even remember what happened, but either nothing happened or something happened. like the egg opened or something. It was literally a picture of something and an event listener for the tap event and a counter. So anybody here could probably implement it today, but who would know that such an application would actually be installed and used by people? So if you look at these at the apps that are being used, you will see that there is a imbalance. Not everything that is very, very hard to implement, difficult to processing app, something that is solving a very, very complicated problem, is also viral. And not everything that is viral is very complicated. It can be a very, very simple thing, but the idea can be more important. So this is outside the scope of this course, but it's more or less figuring out what target audience am I building to, and what are they interested in. And this is usually far away from what you as the developer are interested in. So I'm not interested in making this tap counter. But then again, maybe I should be if I want to focus on some specific target audience. Okay, but anyway, so if you have questions or things, anything you want to talk, I think you can always ask, and otherwise we can end earlier today. So next week I will start building the mock-up, building the app that I'm going to build here. I decided at the conference I'm going to build an app that gives you navigation instructions so that you avoid the wind. The reason is that about 3 applications at the conference, 3 papers at the conference, were avoiding the sun or taking advantage of the sun. This is now debatable. So they were saying that, hey, look, in New York there are these very, very tall houses, very tall buildings, and look, this road has no sun ever. It is in such a bad place that it never gets sun, and people who live there never get sun, and they need to go to some places with sun, and how to route them, whatever, some kind of weird things. I saw this problem also about 5 years ago, maybe in another conference. People in Italy wanted to avoid the sun because they are getting ill from too much sun. So they needed how to go from A to B in the shadow. And they were even going outside with the phone and their light sensing sensor, to gather ground truth, what streets are more sunny and what streets are not so sunny. So from research perspective, they did this kind of investigation. I'm not going to go to those levels. I'm just going to use API for the weather and maybe find the buildings and somehow suggest places that you get shelter from the building because the wind is blowing from opposite direction. I'm not going to go in fluid dynamics or some physics simulations. I'm just going to do a simple application that shows you where there may be wind. So shelter from buildings or forest or things like that. So I'm going to show how to use some kind of data and either just show where there are winds or actually even route you using some Dijkstra's algorithm. But anyway, so yeah, thanks. See you next week in